Greetings, everyone. So I want to go over the homeworks very quickly. The first one was number 3, but you actually first have to do number 1 before you can do number 3, right? So we had banana, peach, apple, pear, coconut, mango, and papaya. And as given, we have to make a search tree, a binary search tree for them. So that means we have no choice. We have to put banana first, although that's alphabetically kind of a bit not in the middle. But okay, you will see that that also means that our tree will tilt to the right. We take peach and we compare it with banana, which is to the right of it. Since the right doesn't exist yet, I make it. The right child doesn't exist, I make it a child. Apple, that would be a left child of banana, which also doesn't exist, so I make it apple. Pear. Pear is to the right of banana, and so, okay, they go right, and there I meet peach, and I compare with peach, and that is actually still to the right. Since it doesn't exist, I make a new child. Coconut. Coconut is to the right of banana, right? Then I compare it with peach. Well, it's smaller than that, so we have to go left, but there is no left, so I make a left. It's cocoa. Mango. Mango is alphabetically after banana, before peach, after cocoa. So I have to go this way, it doesn't exist, so I make it. So this is mango. Papaya. Banana. Peach. Oh, it's papaya is before peach, it's after cocoa, it's after mango, so it will go here. Okay, and so if I now, for instance, so number 3 asks to find first pear, I guess, yeah, pear. Of course, it's there, so we're gonna find it. We compare with banana. Pear is alphabetically afterwards, so then we have to compare with peach, and we find pear, and we are there. So after 2 steps, we already find that pear is there. Now, some of these, of course, will take longer because they have a longer path before we get there, right? How long does it take to find a word is exactly the level that the word. So papaya is 1, 2, 3, 4. So it will always take 4 searches to find that papaya is there or not. Now, what if something is not there? Let's say kumquat. We cannot predict how long it will take before we know that kumquat is not there, so let's see. It is bigger than banana, it is smaller than peach, it is bigger than cocoa, it's smaller than mango, and at this point, since there is no left child, I know that kumquat doesn't exist. So, after 3 steps, I would know kumquat doesn't exist. Okay, what about orange? Bigger than banana, less than peach, bigger than cocoa, bigger than mango, less than papaya. O, P, right? So we have to go left. Since it exists, I have to put orange there. You see the search tree even takes longer. All right, and that's how the binary search tree looks like. Now, number 11. You have 4 elements, A, B, C, D, and they have to be sorted. And the question is, so we have a list of n elements. In this case, this is 4. And we know that there are 4 factorial possible arrangements, orderings, right? So this is 24. And if we have a binary search tree, will at each stage we will do a comparison between 2 of the 4 elements, and what we want is at the end to have the leaves of such a tree should be all the possible combinations. So there should be exactly 24 leaves, each labeled by one of the possible arrangements, and then the path should lead uniquely to that leaf. In how many steps? That's now the question. What's the optimal you can do? What's the best you can expect? The best you can expect is this. We know by the formula that 24 is less than the arity. It's a binary tree, 2 to the power the height of the tree. And so this is the height that we have to calculate. So if we take the log 2 of both sides, then this is h has to be at least this much. Now h is a whole number, so it's at least this much, the ceiling of log24, which is 5, because 16 is smaller than 24, 32, the next power of 2 is bigger, so 5. So the height has to be at least 5 of any comparison tree that you want. If it's a correct search tree, then it has to have at least height 5. The question is now, can we construct one like that? And I must admit, this is not an easy problem, and it took me quite a long time to figure it out, and I hope I have finally figured it out for you guys. So here we're going to start. And the way that I explained it for 3, that was correct, but it is much more complicated when you're dealing with more. Okay, so please bear with me. I'm going to try to explain this, how to do this. So I'm going to start a list as unordered. Now, I'm going to have to keep track of a lot of information, and it looks to me that enough information is if I write down all the possible of all the change that I'm sure of. So if I know that A is less than B, then I put them together, A, B. So in the beginning, what do I know? Well, I don't know anything, right? I have A, B, C, and D. So if there's a vertical line, it means these are different combinations that I don't know how they fit together. Okay, I don't mean to say that A is smaller. This means I don't nothing. And then I'm going to always compare 2 of them. So let me do that by why do I do this? Let's compare A and B, right? Why not compare the first 2? So there are 2 outcomes. Let's bring them a little bit to both sides here. What are the 2 outcomes? Well, either A was less than B, and then we have, now what does that mean? If A is less than B, I know that we have this chain. Now A and B is now, we know this order, so I'm keeping track of it. But as far as C and D is concerned, I have no information yet. So that's how I label that vertex. Here I know that B is the opposite. B is less than A, but again, C and D, no information. Okay. Now I want to garner as much information as quickly as possible. So there are a couple of things I could do here. I could compare C with B or C with A. That would tell me where in this string it goes. Or I could even do better and say, let's compare C and D. So at least that we have a bit of both knowledge of both of them. So that's what I'm going to do. So I'm comparing C and D here. And so the same here. So what does this lead to? So if C is less than D, then I'm in this case. If it's the other way around, why is this so long? If it's the other way around, then it would be D is less than C. Okay. Now let me continue on this side here, because otherwise it gets a bit confusing what we're doing. Perhaps you understand better. Now, okay. So there are a couple of things I could do. I could compare B and C, and if B is less than C, I'm done. Well, because then I have the total order. But if B is not less than C, then I have not that much information that I want. So I want to make sure that at each stage I know at least one more. So what I'm going to do is, for instance, comparing A and C. Let's compare A and C. Whichever is the smallest, I can put in front of the other, right? And I will have at least sure about the chain of length 3. So I'm going to compare here A and C. Okay. So what are the 2 possibilities? So either C is less than A, and then no, A is less than C. Remember, left is also that. Let's be consistent in our choices. So A is less than C. That means that what I know is that if A is less than C, then I know that we have ACD. So actually, the second part here, I'm gonna write it here, ACD, and A and B. Okay, I never lose that information, right? So if A is less than C, then this is the 2 types of information that I have. I know that A is less than C than D, and I also know that A is less than B. Okay, that's what I mean to say here. In the other case, what happens now? If C is less than A, well, then I have this chain for sure, and the other one, I don't have that chain already, so I'm not losing that information. At no point I want to lose any information, right? So let's continue now. So what is missing here? So what I need to know now is, where does B go? Should B go? So yeah, I know that B is at least here. so B could either be less than C or bigger than C, or perhaps even bigger than D, right? So we don't exactly know that. So let's compare B and C. At least if I compare B and C, that will give me extra information of where I'm located. Okay. No. Okay. So what did I say that I was going to do? B. Yeah, that's not going to work. I'm going to have to do this because things are getting too small. I'm going to have to just put a little lines. These are the two I'm going to compare. So either B is less than C. What does this tell me? Well, in that case, I have full information, because if B is less than C, then I know the B should be at this side, but I know it's also bigger than A. So I get A, B, C, D. A, B, C, D. So I get full information here. What happens in the other case? If then I know for sure, well, I know, what the things that I know is then A, B. I know that, what do I say? Yeah, I would know ACB, right? That one I would know. I would also know that ACB and ACD, yes. Sorry. Right, okay. Right, I repeat. If C is smaller than B, then I know where C goes in this part. It goes in between, and doesn't give me any information about B. I don't know where B goes in here. Sorry, I'm pointing, but you don't see it. So repeating, if compare B and C, since we are going right, it means that C is smaller than B, right? So let me write it here in case you might not follow. So C is less than B. That means that I know exactly where C goes in here, in this part, because I know already that C is bigger than A, so C goes in between here. Now, do I know where B goes in this side? No. I know it goes here, but it has to be at least here, but it could be before or after D. So the next thing I have to check is, how do B and D compare? And so there are two possibilities. Either it is as it to the left means nothing changes, so then we know that the result is A, C, B, D, right? D is the biggest of all. If that's not the case, what happens then? Let's think. If D is smaller than B, right, that means that B goes on the other side, right? Yeah, right. So that's just A, C, D, B. Okay, B is now the biggest. Okay, and in both cases, I have the full information, right? The only thing that I needed to know is how do B and D compare? So this is again a leaf. So whenever I have only one string left, the full string left, then I have a leaf. Okay. So let's go on this case. What do we have to do here? Sorry, I'm going to have to make these here. What am I going to compare? So let's think. We know where C stands, but we don't know where how that A and D compare. So let's compare A and D. So we're going to compare A and D. Okay, so if it's true that A is smaller than D, then I don't get much information on this side, because it so sorry, let me write down, because A is less than C. What do I know then? CAB, and what about CD? If A is less than C, then this is definitely, I know. This is for sure. But do I know where D goes in the next one? No, because I don't know how it compares with B. So that's the best that I can do. What do I have in this case? So now this means that C is less than A. So D. We're comparing with D here. Sorry. Sorry. Let me do this over, because I'm not sure whether I did it correct. Let me. So A is less than D. Okay. Now I know. Okay, right. So that I'm for sure it goes between C and D. That part. No, sorry. I know something about here because A is less than D, so A must be in between. So that part I know it is CAD. What do I know of the first part? Can I decide where D goes just knowing that A is less than D? That means that D has to be on this side, but I still don't know where it is with respect to B. So this is a situation that I end at that point. Okay. Now, if D is less than A, let's see what that means. If D is less than A, that means that D has to come before A, but we know it has to become after A. D. So this means I actually know what the actual order is. This is the actual order. So only in this case I have to compare something, and I have to compare the last two again, B and D. So what are the possible possibilities? Either it's this one, B is the smaller, or the other one, D is the smaller. So again we have leaves, and let's see what are the heights here. 1, 2, 3, 4, 5. So far all my leaves are on 5. So I'm good on good track, and I'm kind of almost halfway. So this is always promising. If at this point, if I can do one, if this last one works. Oh no, I've done this. Okay, so now we have to deal with this guy. Okay, so what am I going to compare? What did we do last time? Let's see. I compared the two first ones, right? I compared these two ones. So okay. All right, so I'm gonna copy this here. Sorry guys, A, B, D, C. I need much more space, so I'm gonna do it this way. I'm making it here. Okay, so I'm gonna compare the first two, right? That's what I said, A and D. So there are two possibilities. If A is less than D, what it tells me, it means that I can actually increase my knowledge about the second chain, but I cannot say anything about the first chain. In the other case, if D is less than A, then I can increase the first chain, but the second chain I have no idea what happens. I don't know where A goes yet in the second chain. Okay, so what I'm comparing now? Well, I need to know what happens to B and D. So if I do this here, if it's true that B is less than D, then I know exactly where it goes, because I know it's already bigger than A. So this is the case that B is less than D. However, if D is less than B, I still don't have full information. What I do know is that the first chain can be made in this to this, but the second chain is still a little bit, I cannot do much about. And now I'm going to compare, no, this cannot be, sorry. Let me double check, what did I do wrong? If D is less, D is less than B, sorry, I made a mistake here, right? Let's see, okay, what do we have? If D is less than B, okay, then I know that it is ADB, but I cannot do anything with the second one, ADC. Right, I don't know what I wrote. No, it was not right. Yeah. So what I need to know is how do B and C compare. So I'm going to have to do one more comparison here. So this will result in two nodes. Either B is the smaller, and then I know exactly what's going on, or it's the other way around, and then it's A, D, C, B. Again, we have leaves. Let me mark my leaves a little bit better. These are this leaf, this is a leaf, this is a leaf. I have a leaf here, a leaf there, a leaf there. Now a leaf here, a leaf there, and a leaf there. Okay. 3, 6, 9 leaves. Okay, I think I'm on track here. So I'm going to do one more side, and the symmetry would tell me the other side works well, right? So, okay, what is it that I need to do here? Right, so I need to compare, for instance, A and C, okay? And if A is less than C, and the other case is that C is less than A. Yeah, sorry, it's very non-visual anymore. The visual would help, but it's way too big to write everything up. I don't have enough space to write everything. So if A is less than C, what does that tell me? Well, I know that A is bigger than D, so the second one I can increase. I can insert A there, but I cannot do anything with the first chain. What if, in this case, if C is less than A, well, C has to be inserted here, but I know it has to be before D, right? So this is gives me complete solution. D, C, A, B. So this is full, and this one, and here we go. It's the same thing. Now we have to compare these two. Either it is in the order B is less than C, then we are in this situation, or it's the other way around, and then we are in this situation. So again, we have 3 more vertices, and they all are at length, height level 5. 1, 2, 3, 4, 5. Not all of them. Sorry, these are at length 4, but these are at length 5. And how many do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of what I need to do, and I'm halfway. So it is very clear now that if I do the same thing on the other side, I will get a decision tree. So I'm telling you, this is something, it took me a very long time, I admit, at least 2 hours to figure out that this was the way to do it, and to actually do it in the tree. The textbook gives this very cryptic thing, and it says, okay, assume this and assume that. Yeah, sure, but how to write that down in a tree to do this very efficiently, and to, you don't want to have, the whole purpose is that if once you make this tree, you can give this to anybody, and he can now just simply check, right? So let's assume, for instance, that that A is 3, B is 7, C is 4, and D is 2. Let's see whether how would I arrive at that situation. Okay, I'm comparing A and B. In the first step, I'm comparing A and B. That's what I did here. And we are in the situation that A is less than B. So we get into this node. Then we're comparing C and D, and we see that D is, so let me write down the order actually. The actual order that we eventually have to find is A, D, C, B, right? This is going to be the order that we should find, okay? I'm going to show you that we can find this. So this tells me, at this point I have to compare C and D. So that tells me that I have to go to the right, okay? Right? Anytime if the condition is not fulfilled, you go to the right. Okay, now I'm comparing A and D. 3 and 2, that is still not 2, so I'm going to the right. Now I'm comparing A and C, 3 and 4, that yes, so I go to the left. And now I'm comparing B and C, 7 and 4, so it is not, so here, is this what I want? No, what did I do wrong? Okay, let's start over again. I don't know what I did wrong. So let me, perhaps, sorry, I might have gone, let me write these numbers again here. A is 3, B is 7, C is 4, and D is 2, right? Okay, sorry. Let's do this again. Compare A and B. 3 is less than 7, so you go left. Compare C and D. C is bigger, so go right. Compare A and D. A is bigger, so go right. Compare A and C. So A is, yeah, so go left. Compare B and C, that's to the right. Yes, D, A, C, B. That's the correct one. This is not wrong. That's why I had it all correct. I just wrote down this is wrong. I don't know where I got this from. This is the correct order. See? Okay. All right. This is perhaps more than I was hoping that it would be, but at least you see how these things can work and how difficult these things actually are. There's a reason why sorting algorithms is still pursued. The people are still trying to find very good sorting algorithms, although we know they can never be better than n log n. We still try to find things where sorting goes much better in cases where, in some cases, certain cases we know already a bit more about the given data, and hopefully that makes it quicker to sort. Yeah, so I hope this illustrates you again how difficult these things can be.